Hello, good day everyone. Today we will be presenting a project title which is frequency converter for the course BERC 1313 which is programming fundamental. I want to introduce myself. I am Hariharan, son of Sukumaran. My matrix number is B1224107222. These are my group members, which is Suren, son of Suresh. His matrix number is B1224107225. Next is Naveen, son of Yuvaraja, and his matrix number is B1224109493. The last one is Dhanasilan, son of Balan, and his matrix number is B1224105500. I am start my presentation with the introduction of program. Let's begin with the purpose of this project. The main idea is to create a simple and functional frequency conversion tool using the C programming language. This tool is designed to help users convert between various frequency units, which is Hertz, kilohertz, megahertz, and gigahertz, accurately and efficiently. Additionally, this project serves as a way to practice important C programming concepts such as using functions, handling file input and output, and managing user input efficiently, also effectively. Now let's look at the goals of the program. We aim to develop a text-based menu-driven frequency converter program. Users will be able to select conversion direction and manually enter the value they want to convert. The program will save all conversation results into a text file for easy record keeping. Then the last one is extra features like viewing past results and resetting previous calculation are also included to make the tool more user friendly. Okay, now we are moving to the second slide. To better understand why this tool is useful, let's look at the problem background. Frequency units such as hertz, kilohertz, megahertz, and gigahertz are used widely in fields like electronic communication system and signal processing. Second one is converting between these units manually by multiplying or dividing powers of 10 can be tedious or error prone, especially when done repeatedly. Last one, to solve this problem, an automated tool can help improve speed, accuracy, and convenience. That's where our project comes in. This program provides a menu-based system that lets users perform conversions quickly, reliably, and eliminating the chances of manual errors. Okay, now we are moving to the next slide, which is scope of our project. The main objective of this project is to create a simple and efficient frequency converter using the C programming language that helps users to perform accurate and quickly conversions between hertz, kilohertz, megahertz, and gigahertz without the need for manual calculation. This program also provides a convenient solution for the problem by offering a user-friendly menu interface, reducing human error, saving time, and allowing results to be recorded automatically for future reference. The scope of this project includes the implementation of a text-based frequency convergence system with 4 convergence options, 5 different functions, and a file I/O features to store convergence history in a text file. That's all from me. Thank you.
So this is the flowchart that shows how our frequency converter program works from start to finish. We begin at the start point where the program displays a menu with 7 options. 4 for converting to different frequency units, 1 to view previous calculations, 1 to reset them, and the last one to exit the program. Once the user selects an option, the program checks the input. If the user chooses one of the first 4 options, they will be asked to select the original unit and enter the frequency value. After that, the program performs the conversion and displays the result. It also saves this result into a text file. If the user chooses option 5, the program reads the previous results from the file and displays them on the screen. If option 6 is selected, the file will be cleared and a reset message, confirmation message will be shown. Option 7 will display an exit message and end the program. If the user enters anything outside the option 1 to 7, the program will display an invalid input unit message and return to the menu. So now I'm going to explain the functions in our frequency converter project. On the left, we have the display menu function. You can see from the code that this function simply uses a few printf statements to show the full menu to the user. It includes all the options, converting to kilohertz, hertz, megahertz and gigahertz, and also viewing or reset the previous calculations or exit. This is the first thing the user sees when they runs the program. On the right, we have the convert to hertz function. This code shows that it asks the user which unit they want to convert from, either it kilohertz, megahertz or gigahertz, and also asks for the value. After getting the input, the program multiplies the value depending on the unit chosen and prints the final result in hertz. You can also see the bottom of the function. It calls save to file to save the result in text file for later. For the next slide, we have two more conversion functions. On the left is convert to kilohertz. If you look at the code, the user is asked to choose the input unit, then enter a value. The program does a simple math, either dividing or multiplying, to convert the value into kilohertz. Then it prints the result and saves it to the file. On the right, we have the convert to megahertz. It also works the same way. Based on the user's input, the program performs the correct conversion and prints the result in megahertz. Just like before, it also calls the save to file function to keep a record. Next, this slide shows the final conversion function, convert to gigahertz, and also the function for viewing the previous records. On the left, we have the convert to gigahertz function, which lets the user to convert a value into gigahertz. If you look at the code, it follows the same steps as the earlier ones. The user chooses the unit and enters a value. The program divides accordingly, and then the result will be displayed, and it also saves the result to the same text file. On the right side is the view previous calculations function. This one reads from the file that stores all the past conversions. As shown in the code, it opens the file, reads each line one by one, and displays them for the user to see. The last two functions here are for handling the conversion history. On the left, we have the reset previous calculations function, which we use to clear all the file. The code shows it opens the file in write mode, which basically wipes everything inside. After that, it prints a message telling the user that all the previous data has been cleared. And finally, on the right, we have the save to file function. This function works for all the conversion functions we used earlier. It writes the input value, input unit, result, and output unit into file using fprintf. That's how the program keeps a proper history of conversions.
Now let's look at sample output 1, which showcases the core functionality of our frequency converter program. As you can see, users can choose different conversion options such as converting kilohertz to hertz, megahertz to hertz, or gigahertz to hertz. These parts of the program allow the user to select the appropriate input unit and enter the value they wish to convert. The program then performs the correct calculation using multiplication or division based on metric unit conversion, such as multiplying by 100 or by dividing 1000. The result is displayed immediately and also saved to the text file for future reference. This efficient menu-driven structure ensures that user can carry out conversion quickly and accurately. In sample output 2, we highlight the extended functionalities of the system. Here, users are given option not only to convert between units but also to manage the data. For instance, they can choose to view previous calculation, which reads from the text file and shows all the past conversion results, ensuring traceability and reference. There's also a feature to reset previous calculations, which clears the record file and removes all stored data. These features improve the program's usability by giving users more control and transparency over their activity. Moving on to the sample output 3, this slide outlines the current limitation and sets the stage for future enhancement. Although the program performs all the required frequency conversion, it currently runs in a text-based console interface, which may not be very user-friendly for everyone. It also lacks rebus error handling. For instance, it does not check if the user's input invalid character like letters or symbol instead of number. In future version, we aim to include input validation, introduce a graphical user interface, and potential implement reverse frequency identification, where users input a value and system estimates its like frequency range. This improvement will make the tools even more accessible, reliable, and modern. Next, I will pass to next team member.
Good day everyone, I'm Surin Suresh. My metric number is D122410725 from Group 10. I'll be concluding our presentation with the limitations and suggestions for improvement of our frequency converter program. First, let's look at some limitations. Although the program functions well and meets its objectives, there are still areas that can be improved. The system is entirely text-based, which means it doesn't have a graphical user interface or GUI. This might make it less user-friendly for those who prefer a visual interface. Also, the program only allows one conversion at a time, so users must return to the main menu for every new conversion. This can be time-consuming. Lastly, the program doesn't handle invalid inputs like letters or symbols. If users accidentally enter non-numeric input, the program may crash or behave unexpectedly. Now, let me share some suggestions for improvement that could enhance the system. Firstly, adding input validation would help the program detect and manage invalid entries. This would make it more stable and reliable. Secondly, rebuilding the system with a graphical user interface using tools like C++ with Qt or Python with tkinker or PyQt would improve the user experience by making it more modern and interactive. Lastly, we suggest adding a reverse lookup function. This means user could enter a frequency value and the system would suggest the most suitable unit like hertz, kilohertz or megahertz or gigahertz based on the value. These improvements can make the program more robust, user-friendly and suitable for a wider range of users. That concludes our presentation. Thank you for your time and attention.